Altruism. What makes everyday heroes? Proudly presented by Sherry, Kenny, Junan, and Yuting. Andy was on his way home from the cinema, reliving the latest exploits of Superman. Why do superheroes risk their lives, fighting crime all day or night for the sake of others? Why not use their powers for their own good? What is it about these people that compels them to help, even though it doesn't benefit them at all? Then again, I'm not a superhero. I would never risk my life like that. But just then, an unexpected thing happened. Andy saved the little boy. And though everyone praised his bravery and called him a hero, Andy didn't think he was anything special. To him, all that happened was that he was in the right place at the right time. In this presentation, we are not interested in superpowers or superheroes. We are interested in this thing that turns otherwise ordinary people into superheroes. Altruism. We define altruism as the act of helping someone, especially an unrelated someone, at a cost to oneself. Altruism doesn't have to involve a life-threatening component, and other more common examples of altruism include donating money to others. We will be addressing the following questions. Is there an altruistic personality? How can we facilitate altruistic acts? What are some theories of altruism? And what are the implications and research values of altruism? What neural mechanisms are involved? And finally, we will end with some concluding remarks. What is it about altruistic Andy that helped him to save the little boy when others might have just stood frozen to the spot, unwilling or unable to move? Is there something special about altruistic Andy? As with most other human behaviors, nature and nurture interact and influence altruistic behaviors. A study by Rushton and colleagues on altruistic behavior in monozygotic and dizygotic twins showed that almost 50% of the variance in self-reported altruism could be attributed to genes, with the remainder split between the twins' shared and non-shared environments. This strong genetic component suggests a potential altruistic personality, which researchers have been trying to study for decades. One study in particular found that altruistic individuals were more likely to have an internal locus of control, more belief in a just world, and emphasized more social responsibility and empathy than non-altruistic individuals. These characteristics could be a potential indicator of an altruistic personality. Finally, the hormone oxytocin, which is related to empathy and attachment to loved ones, has found to contribute to the generosity of people when it comes to donating money to others. However, as we will see next, altruism too depends on the environment and the context, which Junan will elaborate on.
As mentioned earlier, studying altruism can help us understand how altruism can be taught or enhanced. Social learning approach. Under this approach, we analyze the interpersonal conditions within the family, peer group, or other social situations which facilitate the development of altruistic behavior. There are three important factors. The first one is reinforcement. Reinforcement can be materialistic in the form of tangible rewards, or social, such as friendship or acceptance. Another factor is modeling. A study by Hammer and Murray found that watching acts of altruism on the television can enhance altruism in kindergarten children. The third factor is role-playing. This is supported by a study by Dolan and Edelberg, which found that providing older children with social reinforcement, such as praising them, leads to more altruistic behavior. As a comparison, the study by Aheimer and Murray found role-playing to be more effective than watching pro-social video in enhancing altruism. In terms of practical application, it has been found that integrating students with emotional disturbance into classrooms significantly raised the altruism levels of their peers. The fairness principle has been found to be a strong predictor of altruism. It is hypothesized that the altruistic behavior of someone who has been asked for help will occur only after the person asking for help has been evaluated. Under the fairness principle, the situation of a person asking for help, if it is perceived as less fortunate, will elicit more help from the helper. You may wonder, how did altruism come about? A theory proposed is the reciprocal altruism, where the cost of helping is offset by the likelihood of the return benefit, permitting the behavior to evolve by natural selection. Social exchange theory is another theory proposed. Under this theory, altruism does not exist unless benefits outweigh the cost. Help only occurs when the overall benefit of helping someone outweighs the cost, which is known as the minimax principle. Using this theory, our protagonist Andy will help because he thinks that the benefits he may get, such as recognition from others, will outweigh any possible cost to himself, such as injury. However, under another theory, the empathy altruism hypothesis, relieving another's suffering is the most important, without concern about cost or benefits. Using this theory, Andy helps because he feels for the victim.
You may be wondering, why do you want to study Andy's altruistic behavior? As we know, altruistic behavior is not just any anomalous action. In fact, it is so commonly observed that it seems to suggest altruism may be a general characteristic of mankind that is ingrained in our biology. Understanding altruism and its neural mechanism can help further our understanding of why people like Andy make certain altruistic decisions, which may appear to be irrational or harmful to their own well-being. Moreover, understanding altruism can help us better answer some basic questions about our evolutionary history, such as, why does natural selection favor altruism? And how is altruism useful to the genes? By studying altruism, we can also relate characteristics of altruism to Big Five personality dimensions. Understanding altruism could also further the development of many other areas of study. Take, for example, economics. In economic theories, rationality is an underlying assumption. The prevalence of altruistic behavior goes against the basic assumption of rationality. By studying altruism, we can further our understanding of such irrational economic behavior, and this could help refine economic theories and model. Also, understanding altruism and its neural mechanism has its value in social policy formulation. With a better understanding of altruism and its neural mechanism, we can answer questions such as, under what circumstances will people be more altruistic? Or how can we encourage volunteerism? We can also answer questions like, which group of individuals is more likely to volunteer? With the answers to such questions, policymakers can better formulate policies to effectively encourage social assistance and volunteerism. Also, research on altruism and its neural mechanism could help us unravel the nature versus nurture mystery. Studies have found altruism to have a strong nurture effect. By further studying altruism, it can help us understand how altruism can be taught. There could be great benefits to society and individual himself in terms of its potential to increase happiness and wellness. In the next section, Kenny will elaborate on the neural mechanism of altruism.
Thank you, Yuting. What areas might you expect to be activated when Andy saves the child from the car? Many of us will say that we do not actually gain anything from helping others out. Some others believe in the joy of giving. If you think about it carefully, when you perform an altruistic act, do you think that you will feel happy with yourself? Moore and colleagues have shown that donating to charitable organizations resulted in the activation of the mesolimbic reward system using fMRI. The mesolimbic reward system includes the midbrain ventral tegmental area, the dorsal and ventral striatum. These areas, as expected, were activated when participants received monetary rewards for themselves, as well as when they decided to donate selflessly. In addition to the mesolimbic pathway activation during donation, the subgenual area, which is densely interconnected to the mesolimbic, dopaminergic, and dorsal, Raphael serotogenic pathways, was more active for donations than receiving monetary rewards. This area was also activated when partners look at their babies and romantic partners. As we see from the diagram that the dopamine pathways are connected to the prefrontal cortex, Moore and colleagues also found that the anterior prefrontal cortex is activated when altruistic choices prevail over selfish material interests. We can imagine that Andy has to make a complex and costly decision before deciding to save the boy from the car. This employs the prefrontal cortex, which has been known to be active in decision-making processes. Hence, altruism requires this same region to be activated due to one's self-interest and moral beliefs being in conflict. As these areas are associated with the reward system, the social exchange theory may argue that Andy saved the child because he would receive an internally satisfying reward after saving the boy. As the potential cost of this action is much larger than the potential rewards received, one may argue that rewards alone cannot be the only factor that motivates Andy to save the child. Now, take a moment to think about what Andy would experience if he did not save the child. If you were in Andy's shoes, would you feel guilty for not saving the child? This brings us to the idea of altruistic guilt. Andy might have saved the child because he wanted to avoid feeling altruistic guilt had he not reacted to the situation. In fact, Basir and colleagues, using an fMRI paradigm, found a region of the brain that is associated with altruistic guilt. We know that previously, the prefrontal cortex could be activated during altruism because of a decision-making process in altruism. Here, the results of the study suggest that the anterior medial prefrontal cortex were activated when participants were shown sad faces, followed by sentences stating how lucky the participant is and how unlucky the person in the picture is. These sad faces elicit altruistic guilt, as participants feel sad for the person in the picture and could potentially result in helping behavior. In previous studies, this area has also been activated when participants experience social and interpersonal emotions, as compared to inner and private emotions such as sadness. This supports the empathy altruism hypothesis, whereby we are likely to help others without any selfish thoughts, because we are able to feel for the person who requires help. When the anterior medial prefrontal cortex is activated, it is likely that Andy could empathize with the boy's situation, and hence save the boy, as compared to a reward-based explanation for his actions. We know that from previous literature that when participants reason about others' mental states than reasoning about non-human objects, the posterior superior temporal sulcus was activated. This same area was activated in Tendensky and colleagues' fMRI study when participants watched a computer play a game to earn money for a charity of the participant's choice rather than typically earning money from themselves. In the study, low altruistic participants had low levels of PSTC activation when either watching the computer play for them or when they are playing. Participants high on altruism showed a greater activation of right PSTC as compared to participants low on altruism. It is then possible to predict the level of altruistic behaviors based on the amount of activation of the posterior superior temporal cortex. So, the higher your activation of PSTC, the higher your altruism is, as this area is also activated in previous research on reasoning about others' mental states. The results of the studies support the empathy altruism hypothesis. Going back to Andy, it is possible that his posterior superior temporal cortex activated because he was able to think about the safety for the child, and hence resulted in his helping behavior. We hope that from our earlier discussion, we have helped you to better understand altruism from the behavioral and neural perspective. As we have mentioned earlier, from a social learning approach, altruism can be nurtured with reinforcement, role-playing, or modeling. Other reasons on why people are altruistic can be explained by the social exchange theory and the empathy altruism hypothesis. Although the two theories may be competing, such as the differences in brain activation patterns, they could actually be complementing each other, as couched in different terms. As altruism is part of a higher cognition, it is unlikely that only one area signals altruistic activity, as even simple behaviors unrelated to altruism could cause similar patterns of activation. After all, altruism can take many forms, such as donations, helping an elderly person cross the street, or even taking a great risk by saving a life. In our presentation, we have covered some of these areas that could be activated in altruism, but there could be potentially more neural regions related to each form of altruism. Further research or better neural imaging techniques could help to shed light on a specific neural mechanism related to a specific form of altruism. We hope that our presentation has managed to provide some useful information about the biological, social, and neural aspects of altruism and increase your interest in the topic. Thank you very much for your time.